Okay, so last time we stopped before section D. Now we're continuing on page 44, starting with section D. So section D tells us to explain how you know that each pair of triangles are similar. So we're going to refer to our notes soon, and we're going to think which similarity theorem helps explain that these triangles are similar. So when you're doing the similarity calculations, what you need to do is a lot of division, okay? So you're gonna see a lot of fractions. So it's a good thing if you guys get over a fear of fractions now. No need to be scared of fractions, okay? So looking at this, we have this side that looks like it corresponds with this one. So I'm gonna divide these two blue sides. It doesn't matter which order you do them in, as long as you, like if you choose this triangle to become top, then you're gonna always keep it as top. And then if you choose this one to be your top, then you can always keep it as top. So just for the sake of example, I'm going to say this one's going to be the top and this one's going to be bottom. Okay, so I'm going to say 3 divided by 6. So I put the 3 on the top and I put the 6 on the bottom. Let's try the other side as well. We have a 4 and an 8. These look like they are corresponding. They're on the same spot on the triangle. So remember that this triangle goes on the top, so I'm going to put 4 on the top, and then this triangle goes on the bottom, so I'm going to put 8 on the bottom. And let's see, are these fractions the same thing? So if you don't immediately know that the fractions are the same thing, you can always type it in a calculator as well. So for example, I can tell that 3/6 is the same thing as 4/8 because they're both 1/2, okay? But if you don't know that, type it in a calculator. What is 3 divided by 6? You're going to get 0.5. What is 4 divided by 8? You're going to get 0.5. And so if fractions are absolutely horrible to you and you just don't want to deal with it right now, then type it in your calculator, and if it comes out to the same number, you have similar sides. So we just discovered that the blue sides are similar and the purple sides are similar. What do we see in between them? Well, we see a right angle between them and this triangle, and we see a right angle between them in that triangle. So there's an included angle that is congruent. I'm going to write that. Included angle is congruent. Okay, and so just so you know, if you if you're just lagging, you didn't have audio, your internet kicks you out, don't worry, I am recording this. It will be posted to the website later so that you can always watch it, okay? So we just have the included angle is congruent and we have two sides. So let's see, which similarity theorem should we be picking? Side angle side similarity theorem, where you have two pairs of corresponding sides being proportional. So they were both 0.5, so they're both proportional. And the corresponding included angles are congruent. They were both 90 degrees. So we have SAS similarity theorem. So I'll write over here, SAS similarity theorem. So we know it is similar because of the SAS similarity theorem. So that is our explanation. It's the SAS similarity theorem. Any questions on part D number 1? All right, let's go to part D number 2. So part D number 2, we have 3 sides labeled on each triangle. And so I'm going to divide them to see if we get the same proportions. Are these sides proportional? Let's take a look. So we have this one, which is 4, which corresponds with this one, which is 12. Let's mix it up a bit. I'm going to choose this one as the top triangle and this one as the bottom triangle. It doesn't matter. Just make sure you're consistent. So over here, I have 12 divided by 4. Okay, so the top triangle is 12 and the bottom triangle is 4. Then we have, let's pick another corresponding side, the right side. This one's 4 and this one's 12. So divided again, is this equal to 12 on the top, 4 on the bottom? And then let's test out the last side. We have 21 for the top and 7 for the bottom. And let's take a look. If we divide all these, will we get the same answer? 12 divided by 4, that fraction is equal to 3. 12 divided by 4 again is just 3. 21 divided by 7 is 3. We got the same number every single time, so we have proportional sides. I should write the word proportional. And over here, this was also proportional. So we have 3 proportional sides. Okay, I have a question over here. It says, for number 1, why couldn't you do 6 divided by 3 or 8 divided by 4? 6 divided by 3, 8 divided by 4. You can totally do this. I was telling you earlier that it doesn't matter which triangle you pick as your top and bottom, as long as you stick with, like if I picked this one to be top, then I need to always use this one as my top. But I said, for my example, I have to choose something, right? So I chose to make this one my bottom and this one my top. So then I just stuck with that. So if you do 6 divided by 3 and 8 divided by 4, it works also. Same thing, as long as you just are consistent with which triangle is your top, which triangle is your bottom. You need to stay consistent for yourself. But it's just, for the example, I have to choose something, so I just chose it the other way. So yeah, here we have a proportional triangle. We have 3 proportional sides. Which one in our notes has 3 proportional sides? SSS, standing for the 3 proportional sides. 2 triangles are similar if 3 pairs of corresponding sides are proportional. So we have the SSS similarity theorem. Let's write it over here. SSS similarity theorem. Okay, good question. Any other questions? All right, let's go on to another section then, for like the next problem. We have over here 2 triangles for number 3, and let's mark them. This one says 40 degrees. This is also 40 degrees, so I know that there's a congruent angle there. We have over here 60 degrees, and over here also 60 degrees, so I know that angle is congruent. So we have 2 pairs of congruent angles. Which one has 2 pairs of congruent angles? I'm just writing it out. You don't necessarily have to write that. So let's go over to our notes and look for which similarity theorem has 2 pairs of congruent angles. There we go. AA similarity theorem. Angle, angle. 2 angles. So AA. AA similarity theorem. Alrighty, there we go. Any questions on this one? All right, I'm going to skip number 4 just because it's similar to something we've already done. I'm going to go over to number 5. So number 5 is a little bit trickier because, because it just looks different, right? So it's trickier. But anytime you have this thing going on where you have 2 lines intersecting, this is a pair of vertical angles. So those 2 blue angles that I just marked, those 2 angles are congruent. Okay? Those 2 angles are congruent because they are vertical angles. You have to remember vertical angles In math, you can't just forget something that you learned last chapter. Everything builds on each other. So remember what vertical angles are from the very beginning. It's when you have essentially like a bow tie. If you can make a bow tie with it, here's my bow tie. If you can make a bow tie with it, they are congruent. These are congruent angles. So we have one congruent angle there. And then I also want you to pay attention to this square over here, which represents a right angle. So we have two right angles. Right angles are always congruent because right angle means 90 degrees. And then we have the blue angles being congruent. So what we have going on here is two pairs of congruent angles. And so once again, two pairs of congruent angles is the AA similarity theorem. Any questions on this one? All right, so let's go on to number 6. So number 6 is another weird looking example, but it's important for you to remember things that we've learned in the past, okay? So as you can see, these two lines are marked by that little arrow in the middle of it, which means they are parallel. So we have parallel lines, and these parallel lines are being cut by this transversal and this transversal. So we're going to be talking about alternate interior angles, same side interior angles, stuff like that, okay? Okay, so when you have two parallel lines like that, just remember that these two angles are congruent, and also on this right side, those two angles are congruent. And that's because you have parallel lines cut by a transversal. So just see that we have two pairs of congruent angles, and once again, this would mean we have a similarity theorem, because those are corresponding angles. Okay, any questions for 5 and 6? Looks like a no. Okay, let's do 7 and 8. Let me just double check the time. Okay, we're good on the time. All right, so for 7 and 8, let's take a look. We have on number 7, it looks like the triangles could be similar, but they're reflected. So let me show you that this side corresponds with this side, right? And then we have this side corresponding with this side. And then we just need to pick which one we want to be on top, and we're just going to stick with it. So I'm going to just pick this one because why not? Top, bottom. It's okay if you did it the other way. It's totally fine as long as you are consistent with it. So let's do the green sides first. So the top 3 divided by the bottom 6. And then let's see, is that the same fraction as the top 4 divided by the bottom 8? So are these proportional? Let's take a look. So some of you might be able to tell if they are proportional immediately. They are both equal to 1/2. These fractions both simplify to 1/2. And so if you don't know, you can just type it in a calculator. 3 divided by 6 gives you 0.5. 4 divided by 8 gives you 0.5. They come out to the same number. These are proportional. So since they are proportional, let's take a look at the included angle in between them as well. So this is the included angle. Included just means it's in between the two sides. So in between our blue and green sides on each of them, we have a right angle, which is congruent. We have two congruent right angles. So I'll write congruent included angle. Remember, included angle means it's just between the two sides that we're talking about. So the included angle is congruent. Then, according to our notes, we have a side that's proportional. We have an included angle that's congruent. And then we have a side that's proportional. Side, angle, side. SAS, Similarity Theorem. Side, angle, side. We have two sides and the angle in between. Any questions? Okay, let's do number 8. Number 8 is an interesting one, I think. So we have two triangles, and they're kind of like one of them's inside the other one. So the baby triangle is inside the big triangle. And so when you're doing this, let's first notice the right angle that they put over here. So we have a right angle on the big triangle, and on the little triangle, we also have a right angle over here. I know they marked it on the left side, but if there's a straight line on the bottom and you have a right angle on one side, the right side's also a right angle. So we have a pair of congruent angles here. We also have this angle, angle E. Angle E is shared by both triangles. Angle E is part of the big triangle. Angle E is part of the little triangle. And so we have two pairs of congruent angles. We have the yellow angles that are congruent, and we have the purple angle that's congruent to itself. And so this will bring us to the AA, or the two angles, Similarity Theorem. Okay? Any questions? Okay. Let me see which problems I should be skipping so that you don't get overwhelmed by me just talking at you. All right, let's do 3 problems from the next section. So moving out, going to section E, we're gonna do 1, 2, 3. Sounds fine. Let's do 1, 2, 3. Okay, so for number 1, it says, what information would you need to use the angle-angle similarity theorem to prove that the angles are similar? So we're just gonna draw it on our pictures. So they gave us that this angle is 35, and then they gave us that this angle is 60. And we want to be using the angle-angle similarity theorem. So in order to match up our two triangles, we need this angle to be 35 degrees as well on the right triangle. And on the left triangle, we need this angle to be 60 degrees. If we have this information, then we would have two pairs of congruent angles on the triangles. And that would help us get the angle-angle similarity theorem. Because for angle-angle, you need two angle pairs, right? So we need to make sure we have the two angle pairs. Any questions? Okay, let's take a look at number 2. What information would you need to use the side angle side similarity theorem to prove that the triangles are similar? So notice that our triangles are not oriented the same way. They are facing different ways. So like this one's standing up and this one is lying down. So the blue sides that I just marked those are the corresponding sides. Do you see that? So I have the short leg as the corresponding side. And then we have this one, which is 10 meters. And this long leg corresponds with this vertical side. So we kind of have our triangles flipped around. Okay? And then last but not least, we have a right angle in between. So for the side angle side similarity theorem, you would need a side. So for example, our blue side, and then we have the angle, the purple angle in between, and then we have the yellow side. So we have all of them marked down, except that we are missing one piece of information. What is the side length for this small yellow side? So we need to solve for this. Let's call this x. Okay, so since we don't know what it is, we're going to call it x and we're going to solve for it. So we have to set up our proportion. Let's choose this one to be the top triangle and this one to be the bottom. Okay, so we have the blue fraction, 6 divided by 4 equals the yellow fraction, 10 divided by x. I'm sorry, I should not have used yellow, but let me write it over in black. 10 divided by x. So that's our yellow fraction. We set it up and we know that they're equal because they're similar, but we need to solve for x. So how do you solve for x? Take a look at our notes. Solving proportions, you cross multiply like a butterfly. The butterfly method, okay? Cross multiply and then we solve. So we're going to cross multiply. 6 times x is equal to 4 times 10. And then we divide both sides by 6. X is equal to whatever 40 divided by 6 is. So I got 6.6 repeating. So the information we would need to use the side angle side similarity theorem to prove that the triangles are similar is, let me highlight it, is this piece of information right over here. This is the information we would have needed. So this highlighted piece of information is what we needed to use the side angle side similarity theorem to prove that the triangles are similar. Any questions? Okay, let's do one more on this section. What information would you need to use the side similarity theorem to prove that these triangles are similar? Okay, so let's mark which ones are even corresponding. So they are oriented the same way. Oh, I guess I could just highlight that. These blue sides are corresponding. We have these purple sides are corresponding, and we have these green sides are corresponding. So we need to set up our proportions and solve. Let's call this one x and this one y. For the side similarity theorem, we're going to need all the sides. We're going to need to know all the sides. Okay, so let's set up the blue one. Let's have this one be top, this one be bottom. So top blue is 12 divided by bottom blue is 6. This should be equal to top purple is x divided by bottom purple is 5. This should be equal to top green is 14 divided by bottom green is y. So we're going to solve, okay? Before we solve, any questions on how we set up our proportions? Okay, So let's divide it out, or let's do the cross multiplication. Let's focus on these two first. So I'm going to cross multiply 12 times 5. That gives me 60 is equal to 6 times x, 6x. Let me rewrite that over here. 60 is equal to 6x. And then to solve for x, you're going to divide by 6, and then you'll get 10 is equal to x. So I'll put that over there. That's one of the pieces of information we needed. Any questions on how we got x? All right, let's get y. So in order to solve for y, I'm going to rewrite our blue fraction over here. So it's 12 over 6. Remember that 14 divided by y is going to be equal to 12 over 6. So let's focus in on this one now. I'm going to write it over there. Cross multiply. 6 times 14. Don't know what that is. Going to type it in the calculator. It's 84 is equal to cross multiply 12y. Then divide by 12, and you get 7 is equal to y. That's a 7. Such an ugly 7, I'm so sorry. But 7 is equal to y, and 10 was equal to x. So we have our two pieces of information that we needed. Let me highlight the two pieces of information that we just solved for. We got that this side is 10, and that this side is 7. That's what we needed to use the side similarity theorem. Any questions on this one? Okay, part F is so similar to part D that I'm going to skip part F just because I know, I can just tell that you guys are tired of listening to me talk. So since you guys already have examples for part F, we're going to scroll past it, and I want to take us to the last page, which is page 48. I'm just going to write it over here. Oh my goodness. Page 48, and then we're doing section G, okay? So go take a look at page 48, section G, and then we're going to do this part together. So use each similarity statement to write the corresponding sides of the triangles as proportions. So we're going to do this for sides, okay? There's 3 sides of a triangle. And so it might help you guys to see a picture of this, so I'm going to just draw a picture. If you don't need the picture, you don't have to draw it. I'm just going to draw 2 triangles that look roughly the same. And then I'm going to label it. If I have C first, I'm going to put C, and M first, I'm going to put M. Okay, wait, hold on. This stuff is too close together. Oh, it's fine. Let me do this again. So here's my similar triangles. I'm putting them in the same spot just so that you know they're corresponding, okay? And then if we have G and K second, this one will be G, this one will be K, and then the last one, L and P. So this hopefully can help you visualize that the 3 letters, the order matters, okay? So if C and M were first, they are corresponding. So I put them in the same corner. So put the letters in the same corner on the 2 different triangles. So let's write out our statements. We have CG corresponds with MK. If you're just looking at it in the problem, we have CG is the first 2 letters, MK is the first 2 letters. So you can write that CG is similar to MK. So you can write that the 2 sides are similar. You know that either by drawing a picture or knowing that those are just the first 2 letters. Let's also do the second and third letter. So we have GL and KP. That's these, GL, KP. Notice they're on the same side of the triangle, so we have GL similar to KP. And last but not least, if you choose the first and the third letter, that will give you your third side of the triangle. So first is C, L is last, so CL is similar to M is first, P is last, MP. And you can tell that either by looking at the pictures you drew or by just choosing the first and third letter. So we have written the similarity statements for the corresponding sides of the triangles. Okay. Oh, and I just realized, because I zoomed out, I didn't see. We have to write it as proportions. So I'm going to write them all out as proportions. Let's choose which triangle we want to be the top. I choose this one, and this one's bottom. Okay, so I'm just going to rewrite it out. So for the top one, we have CG divided by MK. So those are the blue. Let's do the purples. GL divided by KP. Let's do the yellows. CL divided by MP. So here are our proportions. This is our final answer. Any questions on this one? Okay, let's do another. Just in case the picture helps, I'm just going to draw a picture for number 2. Okay, there we go. So we have X is first, Y is first, then we have Z is second, M is second, C, and N. These are such random letters. Whatever. Okay, and then I'm going to choose a top and bottom triangle. It doesn't matter. Let's choose this one as top this time. Whatever. If you chose the other one, it's fine. You're just going to have a flipped fraction. Okay, so let's do this one corresponds with this one. So YM and XZ, those are the first 2 letters, right? We're going to divide them into fractions. So YM divided by XZ. So this is one of your proportions. Let's pick the other side. We have ZC, so the second and third letter, and MN, so the second and third letter. So I have MN on the top, and I have ZC on the bottom. And then finally, I'll do it in green this time. The first and the last letters. So the top one is YN divided by XC. So this would be our proportions. Any questions on this one? Okay. So if you don't have questions, I think 20 minutes to start the homework in class sounds like a good idea. That way you guys can have some time to ask me questions about the homework, especially because I didn't get to have office hours yesterday. So I'm going to end the recording now.